Hi, this is Highlander Racing's pre-tag accumulator inspection video, and I am Thisath Perera. I'm the ESO and the battery lead. First, I'll try to highlight that we have the danger high voltage always energized on all faces. So we have the top, we have the side, we have the front, and we have both sides, as well as the back. Yep. We also have the ESO as well as the vehicle number on the top. And I'd like to talk about our setup. And so we have two student designed PCBs. So we have our pre-charge board there, as well as our thermistor and voltage management boards on each subpack. I'd like to also highlight the 4mm spacing rule on any boards with HV and LV. So on our pre-charge board, I have a caliper measured to 4.7 millimeters. And you can see if you look inside, there's a indicator, silkscreen indicator. And if I hold the calipers up to it, you can see that there's definitely more than a 4mm gap. We also have it on our thermistor and voltage processing boards. So you can see that's about 4 millimeters. If you want to zoom in. Yep. Okay. You can also see that we have all our boards are conformal coded, for example. And I'd also like to detail our high current path. So this is our positive terminal and this is our negative terminal. Our positive terminal flows through the main pack fuse, which goes down to our positive air, out to our main connector. Our negative terminal flows from this subpack through our current sensor, through our negative air, through our negative terminal. And we also utilize, for positive locking, we use prevailing torque nuts everywhere. So you can see these are some prevailing torque nuts. I'd also like to highlight that our main pack fuse is the same one as described in ESF. So that is our main pack fuse bolted in, and here's another one. So it is a 125 amp main pack fuse from little fuse. I also have one subpack removed to show that it's insulated on all sides. So we use Nomex paper 410, so it is UL94 V0 as well as electrically insulated for our system. I'd also like to highlight how you can see that there are no orange wires that are energized always, leaving the accumulator. All of our high voltage wires that are longer than 150 millimeters are also fused. So here's an example of one. It is fused, is also fused here and here. You can see that the both positive and negative air as well as the main pack fuse are separated with a divider wall, which is also electrically insulated as well as fireproof. Per rules, it is also required to have the analog devices energy meter temperature sensor connection. So here you can see that's it right there. It is glued with the same adhesive detailed in ESF, and it wires to our thermistor voltage processing board on the top of our subpack module. And you can see it's in the center of the pack on the negative terminal of the cell. So we have a 12S 4P configuration, and so our negative terminals on the cell go this way. And it's on the hottest area, which will be the center of the pack. Our subpacks are insulated not only from the sides, but the top as well. So you can see how the divider walls reach to the top of the accumulator, and our lid is insulated with the same Nomex paper, and the lid goes on and is flush with the divider walls. I'd also like to detail how all our maintenance plugs can be removed and reinstalled without tooling. So here's our positive terminal. Here's our negative terminal. Here are our subpack connections. Removed and reinstalled. I'd also like to show how our subpacks have positive locking for all the maintenance plugs using prevailing torque nuts. And all of the Radlock service connections are insulated. You can see they have covers on them, and they can only be connected at the connector contact point. I'd also like to highlight how it is not possible to connect our subpacks in any of the wrong ways. So you can see here, if I wanted to connect these two sub packs together, which is not how they should be connected, the divider wall is preventing the connection of that. Same for all points on the accumulator. See how it's not possible. We have a accumulator indicator light, detailed high voltage present. It is powered off our tractive system voltage, so it runs from here to our pre-charge boards, which steps down our full tractive system voltage. All our high voltage connectors have interlocks. So this is our receptacle. It is a PL082X-301 from Amphenol. So you can see the two HV interlock wires here running through our harness. And now moving to our charger cart. So here is our charger right here. It is an Alcon 6.6 kilowatt charger. So this is our main charging connector. So it's HV minus and HV plus. You can also see, if you look on the inside, there are two pins for HV interlock. The specific connector model is an HVSL 282022A by Amphenol. So it includes a high voltage interlock. And now we have our charging connector right here. And so you can see this plugs into our accumulator, and then it's fused, and all cables are orange, and this plugs into our main charging connector here. And you can also see on charger card, it has an HV plus and HV minus banana jack available.